Hello, it's time for me to let you in on a secret. So the way we talk about gradients as how much you go up every time you go along one isn't the only way to think about gradients. Sometimes it can be useful to think about gradients of a line as an angle. So consider this line here. I could think about the gradient of this line as saying, okay, from here let's count across 1 unit to here, count up how many units we've gone up, and let's say that I've gone up half of a unit there. So if that's a distance of 1 and that's a distance of a half, then I've got a gradient of a half. Now another way of thinking about the gradient would be to say, what is this angle here? And this angle is normally referred to as theta. What is this angle theta? Because that also tells me how steeply does the line go up. So a theta angle of 0 would be flat, 90 degrees would be straight up, more than 90 degrees, and you've got a negative gradient. So how can I work out what this angle is going to be? Well, we can do it with this numbers we've already got here. It's slightly easier to see with a bigger triangle. So let's just say that, what if I go over at the bottom, if I go over here by 4 units, then I'm obviously going to end up going up by 2 units. So I've got a nice big triangle here that's 4 across the bottom and 2 up. And because counting across is always flat and counting up is always vertical, this is always going to be a right angle in the corner here. So if this is a right angle in the corner here, I can use trigonometry. And for theta, 2 is the opposite and 4 is the adjacent side. So I could say that tan of theta, which is the opposite over the adjacent, is going to be 2 over 4, which is going to be a half. And I can then go ahead and work out what theta is going to be by using that. So I can do inverse tan of a half. I can work out theta equals inverse tan of a half. And you might recognise that number a half. That number a half is also here, that was also the gradient of this line. So in general, we have a fact that the gradient m is always going to be tan theta, where theta is the angle made with the positive direction of the x-axis. So this angle here, how steeply am I going up, we refer to it as the angle with the positive direction of the x-axis. So if I get a calculator here, I can type in something along the lines of inverse tan of 0.5 to get a number. Here we go. In this particular case, my angle is going to be 26.6 degrees. So there we go. We can just do another example just quickly. Let's suppose I have a line that goes something like this. So I'm looking for this angle here. Well, I'm going steeply negative. That's an interesting thing. The gradient, let's just say that if that's a distance of 1 there, that's a distance of 3. Then I've got a gradient here of minus 3. So every 1 unit I go across, I go down 3. Every 1 unit I go across, I go down 3. So gradient is minus 3. And that means, again, you can draw the triangle and see how it's going to work. But that means that basically minus 3, the m, is tan theta, equals tan of theta. And I can do inverse to find out that theta is going to equal, let's do inverse tan of negative 3. There we go. Theta is minus 71.6 degrees. Now, that's not really what I wanted to know, actually. What does this minus angle even mean? Well, actually, this angle here is this angle here. This is 71.6. The negative is because it's gone down, backwards. Rather than counting up positively, this angle is going up positively, the angle has gone down negatively. Okay, so that's 71.6 degrees there. So the easy way to work out in this case and what theta is going to be, is I can say theta is going to be 180 minus 71.6, which is going to be 108.4 degrees. So theta is going to be 108.4 degrees. And there's a few ways I can think about doing that. So if you didn't like the drawings and the taking away from 180, it's useful to be able to relate this anyway to our graphs of trig functions. So if I were to graph tan, it looks something like this. This is called an asymptote. This happens at 90 degrees here and 90 degrees here. And then it kind of pings off the top and straight back on the bottom. And I've got this same shape that's going to happen again over here, like history repeating itself. And this point here where it crosses the axis is going to be at 180 degrees. So I'm finding out that minus 3 is somewhere here, say. And so I can go across at minus 3 to this point here, and I've found out that this is here, 71.6 degrees, that distance there, because this is the x-axis, and going negative 71.6, negative 71.6 gives me the answer minus 3. So what I could then do is say, okay, where else do I get this same answer? Well, it's when I go a distance here of 71.6 degrees. So look, that's 0, same as that. Go 71.6 degrees this way, and I get to minus 3. So start here, go 71.6 degrees this way, and I get to minus 3. So where is this place here? Well, I've started at 180 and gone back 71.6. So I've got 180, take away 71.6, and what's that going to give me? That's going to give me 108.4 degrees. Same calculation as here, and you can see now how this graph works and makes sense given this picture here and where it all comes from, which is really cool. Hope you enjoyed it.